Welcome back my dear friends. A very good morning, good afternoon, good evening to all of you wherever you are in this part of this globe. And as you know, this is the DADM 3, which is Data Analysis and Decision Making 3 course under the NP Dale MOOC series. As you know, this course total duration is 12 weeks, which when converted into number of contact hours is 30 hours and number of lectures would be 60. That means each lecture is for half an hour, and each week we will have 5 lectures. So, after each week we will have assignment. So, considering that you are or we are in lecture number 9, which is in the second week, you have already taken assignment number 1, and after the 10th one we are all set to take up assignment number 2. And my good name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing about utility theory and the consequences and how they can be utilized for optimization. So, I will try to basically further proceed in the concept of utility theory, try to wrap it up by the 10th lecture, and then from the 11th one try to start off with the concept of optimization and the related concept, and later on see that how utility theory could also be utilized for the optimization problem. Now, for when we are doing utility theory, to give a very brief preview, obviously all of you are very well acquainted what we have considered. We have basically considered the concept of utility, what is expected value, and obviously based on the fact we can also find out the concept of the variances. Then we consider the different the ideas of non-satiation and how risk lover, risk indifferent and risk hater can be clubbed according to the second derivative of UW being greater than 0, equal to 0 and less than 0, because that will give you the trend how the first derivative is behaving, and obviously the first derivative will always consider to be positive, because we are aware that human beings are non-satiated, that means more you give to him or her, more he or she wants. Then we consider the concept of absolute risk aversion property, relative risk aversion property, and what are the significance of A prime and R prime were discussed. Then we went into the 4 different type of utility functions, and how the properties of A prime, R prime can be utilized to find out the characteristics of the utility functions was also mentioned. Later on, then we went into the concept of certainty value, certainty equivalent value, what it means in the actual sense was also mentioned. And then we proceeded that how you can draw the utility functions considering the 45-degree line where UW is equal to W and so on and so forth. So, we were discussing about the concept of geometric mean maximization. So, geometric mean maximization, if you remember, I mentioned that you want to maximize the overall return based on geometric mean, and obviously we know there are 3 types of means. One is the arithmetic mean, one is the harmonic mean, and one is the geometric mean. And based on that we will try to expand or try to utilize this concept in order to arrive that how geometric mean can be utilized for the maximization process. So, maximizing geometric mean returns is equivalent to maximizing the expected value of the log utility function. So, log utility functions we have already considered is log of UW. So, if you are trying to basically maximize the geometric mean, it would also mean that you are trying to maximize the log utility function. So, there would be one-to-one correspondence between them. Now, for any projects, investments, portfolios or decision making which basically maximizes the geometric mean also are also mean variance efficient if returns are log normally distributed. So, if the returns of the decisions are log normally distributed, then you be rest assured that the mean variance efficient concept would give you the portfolio, which would also be obtained when you are considering the maximization of the geometric mean concept for that portfolio, set of portfolios. Now, we will basically go through safety first principle, that means how safe you want to be considering the basic tenets, that is the decision maker is unable to or unwilling to consider the utility theorem for making his or her decision process. So, you want to be basically play it safe, and here I will try to draw there are obviously diagrams. I will try to draw the diagrams in order to make things much clearer. So, under this methodology, that means safety first principle, people make the decision placing more importance to the bad outcome. That means I am more what do you say, more sensitive to risk being on the negative side than being risk on the positive side. That means, or let me put have our decision, I lose in one case 100 rupees and in another case in the same so called gamble I win 100 rupees. Now, my liking or my good feeling for getting an extra 100 rupees would be there. So, let me quantify it, say for example, on a level of 1 to 10, let me say that I am on a positive level of plus 5 when I win 100 rupees. Now, consider on the other sense that if I lose 100 rupees, so technically that is equally penalized, then my loss or my level of dissatisfaction should also be minus 5 on the other side. But here we will consider that losing would make us more unhappy than gaining 500 or 100 whatever I am saying. So, in that case the level of dissatisfaction when I lose that money would basically be more than 5. In more than 5 in the quantum sense, in the negative sense it will be maybe minus 6, minus 7, minus 8 whatever it is. That means, I am putting more emphasis on the losses in the quantum sense. So, safety first principle can basically be analyzed by these 3 formulas, and if you look at them, they have the essence of optimization in a very simple way. I will try to come to that later on, but it will be repetition. Now, it may not make any significance, but it is basically to inculcate the interest, and later on you will see that they would make sense. So, let me draw the diagram. So, go one by one. So, I will define what they mean. So, let me draw it. So, the first one is minimization of probability of RP being less than RL. So, what is RP and RL? So, word P I am using is for a portfolio and R capital R is the return. So, R suffix P is basically the portfolio returns or the collective decision returns. Now, what is RL? RL is a fixed value which I have set for myself. So, what I set for myself may not be true for you or for the third person, because the reason is that my level of appetite of risk would be different from person to person. So, hence when I am considering RL value, that will be higher or lower depending on the level of appetite one has for risk. So, let me draw it considering the normal distribution to be true. So, this is RP bar, which is the average value of the return of the portfolio, and this is the distribution of RP. Now, what I mean is probability of RP is less than RL. And you will try to minimize it. So, there is a reason also for why I am trying to basically put the minimization sign. Now, consider RL. So, this is RL on the left hand side. So, I want to basically minimize the probability that RL would basically be lying, RP would be lying less than RL. So, this hashed area is basically the area for which RP is less than RL, and I want to minimize it, which means that technically in a sense I am trying to push the overall distribution is normal more on to the right. That means, this red part, the distribution which you see would be moving more on to the right from my side. Technically it means that if it is a normal distribution, then the average of RP is increasing. That means, RP bar is increasing and going more to the right, which means that if I am more happy with the higher values of RP bar on an average, it also means that the overall area on the probabilistic sense for some values of RP to lie onto the left of RL would slowly start decreasing. That means, the area will start shrinking. So, this would mean that RP is less than RL. So, RP on the left hand side should shrink. Now, considering maximizing RL. So, consider RL is fixed at some value and my distribution is also given. So, what it says that I am trying to maximize RL, but it does not mean that I am going to shift RL as it is onto the right without changing the distribution, because the overall area onto the left or the value over which I would like the investment to be, which is RL, as it start increasing, obviously the number of assets which I have on the decision variables based on which I am trying to make a decision is there, will also start moving out to the right. So, in general the overall distribution will start moving out to the right, which would mean the value of RP bar would start increasing accordingly. So, the first value also give us a concept the RP bar is increasing. Next one also give us the information that RL maximization will also lead to the fact that RP bar is increasing, and the last one is maximizing average value of RP bar, which technically means the distribution by itself will be moving on to the right. So, if returns are normally distributed, so in this continuation, then the optimum portfolio would be one where RL was the maximum number of standard deviations away from the mean. That means, how far it is from the left or the right, that will come, and the concept of left or right would be relative, considering that you are trying to draw the loss distribution or the profit distribution. I will come to that later on. Let us also consider an example of minimization, probability of RP less than RL. So, remember we consider the returns are normal distribution as we considered, and the suffix P denotes the portfolio, while RL means the fixed level of return, which for our case is given as 5% or whatever it is. Now, if that is the case, the values of RL for A, B, C, RP for the 3 cases are 10, 14 and 17. So, sigma values for so called ABC investments for the corresponding standard deviation of the portfolio values would be 5, 4, 8. So, it would mean that once we find out the differences from 5% or whatever percentage is there. So, you need to find out that 5% of that would be how many times further away from 1 sigma, because 1 sigma would basically cover about 67% of the overall area from minus 1 sigma to plus 1 sigma. So, in this case when we put these values, it comes out to be minus 2.25 sigma beta. Okay. Now, when I am considering the values of B, A and C as the investments, I want to basically find out that percentage difference from the 5% which I have already stipulated as given in the fixed level of return, mean fixed level of return. So, it will mean that the value would be 2. So, the first case would be minus 1 to multiplied by the sigma A value. That means, sigma A value has to basically be shifted onto the left by 1 unit in order that it is able to meet the criteria as it is given in the problem. So, now when I consider sigma B, the value is 2.25 more onto the left, and when I use sigma C, it is minus 1.5 to the left. Now, what is important to know is that these values of minus 1, minus 2.25 and minus 1.5 have been built up considering the standard deviation and the mean value for the investment. So, that would become clear, and this is very true when you are considering the normal distribution. So, here is the normal distribution. So, if you remember, if the diagram which I had drawn, I will just quickly go there. So, here the diagrams are all normal in nature, that means distributionally they are normal in nature, but in general practical senses we would not consider them to be normal. So, this is the safety first principles 2 diagrams. The green one is basically for the decision B. Hence, the mean value which you see, so mean value if you see for RB is the straight line green one, and the corresponding values of the decision A, which is also the mean value, is given by R bar A, and the mean value has been drawn here in order to make one understand that what is the dispersion or the deviation onto the right or the left for the decision A. Now, remember one thing, the more it shrinks, the distribution more it shrinks, even if the mean value is lower or higher on the sun it is lower, then the effect in trying to find out how many standard deviations would be further more not complicated, would basically add up more values. So, what we are doing is we are trying to find out this one. So, which means probability of x minus mu value by sigma. So, this mu and sigma are basically the mu and the sigma for the x random variable is x minus mu by sigma. So, as you are using it, the value of alpha does not change. Now, what does this become? This becomes capital Z, which is standard normal deviate random variable, and this value would basically be some fixed value. Why it is? Because you know mu, you know sigma, then plug it in along the value of x would basically give you the ratio, and ratio means ratio of x minus mu on the numerator and sigma on the denominator. So, you can basically decide where your overall what you call. So, it will help you to find out the values of alpha. Alpha means basically what percentage you are there on to the left or the right. So, if I go back to the diagram, so this would basically be given the value of alpha. Similarly, you can do on the right hand side. So, this value can be increased or decreased corresponding to the probabilities which can be found out from this problem. So, now if I look here in this problem, why it is minus 1 is very simple. I told you it is, so it would be 10 minus this 5 value which is coming from the means of, so RL value. So, it is minus 1 because this is minus, this is plus, it will be 5 minus 10 by 5. So, this becomes minus 5 by 5 is equal to minus 1. So, similarly, if I want to find out this, it would be minus 5 plus 14 divided by 8. So, this would basically become minus 9 by, oh no, sorry, my mistake. So, this is going with, so this will be minus 5 14, this will be 4. So, let us find out what this value, this would be minus, so this will be plus, this is minus. So, this will be minus 9 by 4, 4 2s are 8, and then obviously the value comes out to 2.25. So, when I am talking about minus 1.5, so it will basically be from 5 minus 17 divided by 8. So, that will give you what is the standard deviation onto the left or the right I should go. So, if it is very wide dispersed, so now obviously in that case the denominator and numerator values would dictate that how the strong or weak the dispersion is, how spread out they are. Now, in order to find out how many standard deviation RL lies below the mean, we calculate the value of RL minus the mean return divided by the standard deviation. That is what exactly what I did. So, this is basically equivalent to, you check this, okay, by this value, this is RP bar which is the average value, and technically that should be coming out in the discussions later on. So, minimization of that will be maximization on the negative of that, which means I basically change the signs in the numerator, and then basically what you will find out is that this RL value can be replaced by the so called risk free interest rate. That means, the data based on which you are trying to do the investment for any financial institution, whatever it is, or the bank, and the value which you will get from here would tell you how far or how close it is to the what I should say, how far or how close it is to the values of overall loss which you are going to sustain. So, even though for example, we have simplified our assumption by considering the normal, this is very important point for you to understand. So, even though we have we have considered the normal distribution. So, but this concept would hold true for any distribution provided the first and the second moment exist. Why the first moment exists? Because you are in that case what you are taking? You are taking RL or RF minus the mean value. So, that means the first moment would give you the information on the mean value, and similarly when you divide by sigma, which means the second moment should also exist. Now, according to Chebyshev's inequality for any random variable x such that expected variance and the variance exist, that means the first moment and the second moment exist, then the mod of the difference between. So, now we are basically going to bandwidth. So, shrink it larger such that the constant set basically changes drastically, hence your space based on nils you will do your search would also be minimized. So, according to Chebyshev's inequality for any random variable x such that expected value and variance increase, which would mean the probability of the ratio of the mod of the difference of x minus expected value of x divided by variance should basically be greater than t, and this t you based on our simple assumptions you have to find it out. So, basically this becomes I replace x by r p and obviously of x by r p bar, and the variance now becomes, variance is basically sigma square. So, when once you take out of the square root, value is greater than k value which you will basically find out as it is. So, it is less than equal to 1 by t square. So, t is basically the value of the so called Chebyshev's inequality which you will take in order to solve our problems accordingly. It is basically as a type of bound. So, as we are interested in lower limit, hence we simplify it and write it down. So, once I basically write it down, it comes out to be true that okay. Now, remember the probability of the excess return over the average value divided by standard deviation is greater than some k value. So, replace that k value with a quantity which you know, and then basically corresponding to that the k square value also changes. So, what you are trying to do is that using Chebyshev's inequality, you are trying to basically find out the maximum bound. So, in optimization problem, when you find it, if you are able to solve the problem, then you know that the bounds would give you the maximum limit till which you are able to find the solutions. The right hand side of the inequality is exactly equal to the decision process number 1 under safety first principle we have considered. So, once we consider probability R p minus R p bar divided by sigma is less than R L minus R p bar. So, that divided by sigma. So, that will give me the value of k or the bound maximum to which level this value can change. Now, coming to the next criteria. So, the next criteria basically means that we want to basically maximize R p. So, pushing R p would mean the distribution by itself is also going to the right, which means the mean value R p bar is also increasing. But as I am increasing, the change of the values of the of pushing R L to the right, hence the distribution also changes, would basically mean that the probability of the value which is onto the left hand side from my side based on the area which is left hand side of R L should also be minimized, or it should also be basically given a certain value such that putting that in the constraint would be able to solve you and give you some answer realistically such that you are able to understand and solve it accordingly. So, if I put alpha as 0.05, then we should have the values as shown here, R p minus R p bar by sigma p is less than equal to R L and R p and divided by sigma p. So, that will give you the bound based on which you can do the shifting of R L. So, in this graph what we are looking at, we are finding out the value of alpha. So, alpha can change, it can go from 0.05 to 0.10, 0.20 and so on and so forth. So, but obviously it would mean that as alpha increases, hence the z value which is R L or R p value will also start moving, hence the distribution by itself will be moving. Now, in the safety first principle, if you continue, so basically it would mean that for the case when you are considering moving of the efficient frontier, it would mean that the values would increase such that the combined value of your decision variables such that you are able to maximize R p bar, because R p maximization would also mean that the average value also shifts to the right from my side, and sigma p would happen in such a way that we are able to find out the maximum bound. So, with this I will end this 9th lecture and continue in the 10th lecture with some basic fundamentals of utility theory in the last stage, and then basically continue with more definitions of optimization or in the part of DADM3 as required. Have a nice day and thank you very much.